ever stop and think about what's actually happening inside an AI when you hit enter? There's this hidden brain, kind of like a traffic cop, that's making a huge decision about what you just asked in like a fraction of a second. Well, today we're going to pull back the curtain on that secret system. It's called an AI router, and it is the unsung hero powering pretty much every AI assistant you use. So this is really the core of it, right? When you ask your AI to do something, it's not just one thing it can do. It has options. Should it just chat with you and give you a creative answer? Should it go look something up in a database? Or maybe it needs to fire up a specific tool, like a calculator or a flight booking system. The answer to all of that, it's all about how it routes your request. And just look at these two examples. On the left, you've got something super simple, right? Track order, #123. Easy. A basic script could probably handle that. But then look at the right. Analyze my spending habits and find risks. Whoa, that needs some serious brain power. A one-size-fits-all approach just isn't going to cut it. You need a smart traffic director, a router, to send these two very different requests down the right road. Okay, so let's start with the most basic way to do this. This is level 1. I want you to think of this first kind of router as a bouncer at a club. And this bouncer has a very, very strict guest list. It's not there to think or interpret what you want. Nope, it's just there to check names off a list. That's it. This is what we call a rule-based router. And it's exactly what it sounds like. Its decisions are all based on hard-coded instructions. We're talking simple stuff, like keyword matching or if this, then that logic. It's the most straightforward way to build a decision-making system, but, as you're about to see, that simplicity comes with a pretty big price. So the process is incredibly simple. A query comes in, the router scans it for a keyword, like order or translate. If it spots the word order, boom, it sends the request to the order API. That's just a program that handles orders. If it sees translate, it shoots it over to the language model. For these really specific tasks, it is lightning fast and totally predictable. And that brings us to the big trade-off. Deterministic just means it's reliable. You get the same correct result every single time for a known command. Perfect. But rigid, well, that's its fatal flaw. If a user asks the exact same thing but uses slightly different words, without that magic keyword, the whole system just breaks. It has absolutely zero flexibility. Okay, so that rigidity is a huge problem, right? We need a system that's a bit smarter. And that brings us to level 2. So think less like that rigid bouncer and more like a really helpful librarian who just gets what you're looking for, even if you don't use the exact perfect words. And say hello to the embedding-based router. Okay, this is a huge step up. Instead of just matching keywords, this thing matches meaning. It does this by turning your query into a long string of numbers. It's called an embedding that basically captures its vibe, its semantic essence. So here's how it works. Your query, let's say check my bank balance, gets converted into this special numerical code, its embedding. The system then compares that code to all the pre-calculated codes it has for its tools, like one for account lookup or one for make a transfer. It finds the closest mathematical match and bam, it sends your query there. It actually understands your intent. But here's the thing to remember about this level. It is fantastic at understanding what you mean and finding the right tool for it. It's a great matcher. But it's not actually thinking. It's not reasoning. So it still kind of falls apart when you give it something really complex that has multiple steps. All right, for those really complex tasks, we have to bring in the heavy artillery. This is our third and most powerful level of routing. This is like hiring a brilliant but very, very expensive consultant for every single task, just to analyze the problem and figure out the absolute best way forward. And this is the LLM-based router. Now, we're not using simple rules or math anymore. We are using the AI's own powerful brain, the large language model itself, to analyze what you're asking and make a judgment call. It uses its full-blown reasoning abilities to decide where your request needs to go. Now, this process is pretty fascinating. Your query, something like summarize this document and highlight the risks, gets wrapped inside another prompt. And that prompt asks the large language model, the LLM, to classify it. So the LLM basically thinks to itself, okay, this needs summarization and risk analysis. That's a job for my big brain. And it routes the request to its own core intelligence. And here's where we see the price of all that power. You get unbelievable flexibility. I mean, you can throw almost any weird, complex request at it, and it'll figure it out. But that intelligence, it comes at a huge cost. We're talking cost in dollars for all that processing power and cost in time because it's way, way slower than the other methods. So let's recap. We have fast but rigid, we have smart but simple, and we have flexible but super costly. None of them are perfect on their own, right? So this brings us to the ultimate solution. This is the one that the big production-grade systems from companies like OpenAI and Google are actually using out there in the real world.
And that leads to the big question we've been building up to this whole time. After seeing all the pros and cons of each one, which one do you actually pick? Is there like a single best answer?
Well, the best router isn't any single one of them. It's all of them working together. It's the hybrid router. This is a layered system that literally gets the best of all worlds. It uses the right tool for the right job, combining the raw speed of rules, the semantic understanding of embeddings, and the pure intelligence of an LLM. The logic here is it's beautiful. It's so elegant. Every single query first hits the rule checker. If you ask, track my order, a rule snags it and sends it to the API instantly. This is the fast path. The expensive, slow LLM is never even bothered. It's only if no rule matches and the meaning is a little fuzzy that the query gets escalated up to the big brain LLM as a final fallback. This layered approach is what makes it so darn efficient. Okay, let's bring all this home. We've walked through the 4 different strategies for routing AI requests. Now let's put them all side by side so we can really get the complete picture. This table just lays it all out so clearly. You can see the trade-offs we've been talking about. On one end, you've got rule-based. It's the fastest, it's the cheapest, but it's dumb. On the other extreme, LLM-based. Genius-level intelligence, but it's slow and it's expensive. The embedding router, it's that great middle ground for understanding meaning. But just look at the hybrid model. It's adaptive, it's optimized, it's balanced. It gives you just enough intelligence for the task at hand without wasting a single cent or a single second. And that is why it's the gold standard for real-world systems. And this really brings us to the most important insight of this whole thing. Building a great AI system, it isn't just about having the biggest, most powerful model. It's about making the smartest decisions. The best systems don't just throw their most expensive tool at every single problem. No, they build an efficient, layered decision-making process. They know when to use a simple rule, and they know when it's time to call in the genius. It really is all about matching the right strategy to the right problem.